me show you what this site shows you. I think it worked when I did this before. Yeah.
Chris, do we want to take some time to answer some questions before the video?
Yeah, I'm not going to show the video. No, I'm not showing the
okay.
But I just want you to see, this is such a wonderful site. I'm not going to show, but I promised you I would, but I just did. But it's really easy to do. It's really easy to work. I pulled up CalTopo and I toggled back and forth, and I was pleasantly surprised how easy it was to follow. And you can make maps, a lot of maps like I showed you. Had we been in next year, when we do maps again, I've got pens, eraser markers that we can use, and we can work the maps a little bit better. But sure, go ahead, Casey.
Okay, well, so first, can we go back to the measuring distance? And can
Yes.
you elaborate a little bit more on how you take your string or your paper and compare it to the map scale at the bottom?
Yes. Taking a string is easier. Papers aren't bad. Papers, if that's what you got, that's what you're going to use. Paper, you would turn your paper. Okay, if you have a string and you're going to go from here to here, that's the string. You take your string and turn it to go to here. And then turn the string to go to here and here and here. And then here, you're not going to get exact measurements, but you're certainly going to get close. You can take your paper, start in the corner and go here, and then turn it here, and then turn it here, and turn it here, and follow it along. You can mark it. This is what I do a lot of times, is mark your paper. And then you come to the bottom. I don't know where my graphic line is the other direction. You can take your graphic, you take your string, stretch it out, make sure you're holding the end you started with, no duh, and the end that it went to, take your string, and if it's this long to here, you'll know it's 1 mile and 1/10, 2, 3, 4, 5, 1.6 miles. Using the string versus using a piece of paper. And I find the string a little easier just because it bends a little better.
Yeah, you might have to measure and pinch, and then measure and pinch, and then measure and pinch until you get your full distance.
Is that what you call it? Measure this. See, it goes like that, and pinch, and never heard of pinch. You just got to keep track. Oh, I see what you mean. Pinch. Come to that and pinch it and stretch it out again. Okay, that's good. And
yeah, like if I had more than like a 4 mile route, but the map compass the map scale only shows 2 miles. So I would measure out 2 miles and pinch my string, move it back to the 0, and then measure out again. And that would be how I get my 4 miles.
Yeah, good call. That's great, Case.
And can you go back to the paper slide real quick where it shows all the tick marks?
The depressions?
No, back other way.
This way?
Yep. Keep going. One more. Okay, stop.
Okay.
Right here. So all the ticks on the left side of the screen there.
Yes.
All the ticks on that piece of paper
right there
are at, those are at a turn, because paper doesn't bend. So what you do is you tick,
turn it,
and then you turn your paper, and you go until you hit another current turn, and then you tick, and you turn your paper.
That's right.
Go, and then you tick again until eventually you get to the end of your route, and that's when you can take your paper down to the bottom center of your map. Right and use a scale to measure out.
Yeah. And this stuff is important. It's important to read your map the night before you go on a hike to know. I mean, if you're if you came in on Casey's hike and you went 5 miles, 25 pounds on your back, and he wants to go up that steep embankment, he's going to measure and tell you how long it is, but you need to realize the biggest thing I think with us IMACers is almost like hike your own hike. You know, don't overdo yourself. And if it's I find lately, because I'm getting older, I can only do about 6 to 7, 8 miles a day. I used to be able to do 12, 15 miles a day, but my hips just don't like it as well. You need to know your limit, especially for yourself. And if you're going with a group, it's okay to sit at the camp and read a good book, you know. So, and this will help you find distances, and the contour lines will tell you what that hike's going to be all about.
Yeah, so it looks like Gab has a question about, it looks like we're measuring right to left on our map scale. Chris, do you want to answer that, or do you want me to take a stab at it?
Right to left, the only reason why I measure right to left is because the left has the incremental scale. I mean, if you, like Casey's example of 4 miles, you could go right to left. That's 2 miles. If it's 4 miles, it'll be 2 of those. But if it's 4.3, you're going to need to start at the 0 and do 1, 2, 3, if that's what you mean. I guess I would measure right to left only because you've got your incrementals on the left-hand side of the 0.
Yeah, so it's kind of like fractions.
Mm-hmm.
You start at 0. We say if I had 1.2 miles or something like that, you start at 0 and go out to 1 mile, and then you'll come back to your 0.2.
Okay.
So it can be a little confusing. It's difficult to demonstrate virtually.
Yeah.
But you take your 1.2 piece of paper and you put it on the 0. You go out to 1 mile, and then whenever it's left on the other side, you can read your fraction.
Okay.
And then Anu had a question about how to export your coordinates from Strava to your topo map. George, looks like you got it. You can save your GPS track and export it. CalTopo is a great website because you can import. It'll be a .gpx file. Sometimes it'll be a .kml file. And so you can import your GPS files into CalTopo, or I use Google Earth too. You can import your GPX files into Google Earth, and that's how you can make your cool 3D graphics of your hikes.
And you know, CalTopo tells you that too. You know, they'll literally tell you step by step, use the .gpx, you know, that kind of stuff. I'm tech savvy, not savvy. And I was really pleased with how it taught me. What do you think, Terry?
Yeah, it's very demi-proof. I think just like you said, having 2 windows up, CalTopo up, and the tutorial on it, you just follow it step by step.
Step by step. Yeah, it's really good.
So we had another question. How do you know there's a possible cliff between contour intervals?
Oh yeah, I don't know. Good question. I don't have an answer. How about you? Oh, Mike's yelling in here. Keep your eyes wide open all the time.
Yeah.
Oh, that's Johnny Cash.
Yeah, I would say in theory, it's not going to be more than the contour interval itself. Otherwise, I would have put another contour line there. So it should be a relatively small feature. But the contour intervals do not, the important thing to remember is the contour interval is not going to tell you everything that's there. It's going to be, you know, there can be some features in between the lines.
Yeah.
So another question. How can you tell when you're going uphill versus downhill when you're looking at topo lines?
You can't. I do an activity in my classroom where, okay, guys, you're going to hike the Pacific Crest Trail, and then I'll pat them on the back and say, good for you. Tell me which of these parts of the trail is going to be the hardest. And I said, this is your opinion. And they'll say the one that's got the switchbacks like this, and I'll say, okay, that's fine if you're going, which way is going to be harder? I mean, for us older people whose knees have been around a little bit longer, going downhill is a pain because it's hard on the knees, but going uphill is hard on your lungs. You're going to have to look for a contour interval. This is a good example right here. You're going to have to look at the contour interval here. This is 660. This is 680. So that's how you're going to tell. If you're hiking this way, you know you're going to go downhill. If you're hiking this way, you know you're going to go uphill. Look for the fifth contour intervals. Just work with the fifth one. This is 600. You have to look and see, and the contour intervals never cross each other. They don't cross, so just looking at the main contour, darker brown lines would probably give you that answer. Which is harder, which is easier, it all depends on you. If you want to go up or you want to go downhill.
A good method I use is to find one of two features. The hilltop. So I know if I'm going in the direction of a hilltop, I'm going uphill. And then water, typically your rivers, streams, lakes. If I'm going towards a lake, I know I'm going downhill.
Good call.
So we had another question. When is something too steep, like a steep saddle, when do you start avoiding contour lines?
When you start avoiding contour
I guess can you clarify a little bit? The question literally was, well, what does a steep saddle look like in contours that have to be avoided?
Well, here's a saddle. This I wouldn't avoid this. Would you, Anu? I've hiked with you several times. This is a nice saddle. I think there was another picture in here that was a saddle. I don't know. Casey, you're up.
I'd say it really comes down to personal preference.
Yeah.
What I would say is
I might not hike.
Contour lines do not have to be on top of each other, like cliff-like, in order to make it unpleasant to hike. When they start getting, they don't necessarily have to be touching in order to be a very steep hill.
Right here.
Yeah, right there. That would probably be
right there. Steep. This is right here. I mean, Anu might want to hike that because Anu likes challenges. Chris is going to go like this, and then I'm going to come to the top.
Yep.
This one, look how steep this is. I mean, look here. I mean, yeah. And to be honest with you, to get to this side of the saddle, there's not much grace up there because it's all up. So, yeah.
So I see Dory and Becky are kind of looking into latitude, longitude.
Uh-huh.
And if we can cover that a little bit more.
Sure.
Before we get into it, though, Dory and Becky, I will say we're going to cover coordinate systems next class as well. And we're really going to focus on U.S. National Grid, which is the preferred coordinate system for land search and rescue.
That's the UTM grid?
It's a variation of UTM.
Okay. The northing and easting.
No. It's based on military grid reference system, which was based on UTM. And it was developed by the FEMA after Hurricane Katrina. And so now the Coast Guard says all search and rescue on land at least, should be done in U.S. National Grid. And it's a very user-friendly and easy to remember coordinate system.
It is. It is easy. This Dory and friend, I didn't hear forgot the other name. I'm sorry.
Becky.
Latitude, I mean, the way I teach it in the classroom is lat, lace, flat. You got to remember one of them. You don't necessarily always have to remember two of them, as long as you have the hang of one of them down really good. Lat, lace, flat, and it starts at the equator. Anything north of the equator is north, no duh. Anything south is in the southern hemisphere. This is like 35 degrees. Let me tell you how I start this on latitude, longitude. I start teaching this way. I'll say, my name is Amelia Earhart. And some of them are going, really? Anyway, these are college students. Anyway, it's all good. And I'll say, you know, we don't totally know why she was never found, but it was predicted that perhaps she gave the wrong coordinates. I really try to emphasize the learning of it. And I will say 35 degrees, you got 70 miles between 35 degrees and 36 degrees, 70 miles, too much, way too much. So they took the rest of the coordinate on the clock. They took it for the clock. So it's 35 degrees. This one's 22 minutes. When we get to 59 minutes, we don't say 11:00. Well, no, that's not right. We say 12 o'clock. So at 59, it goes up to the next degree. This is only 1.2 miles. You see her little red rubber raft in the ocean at 1.2 miles distance? That wasn't good enough either. So then they took it one more down to seconds. And so seconds are 0.02 miles. So if you give a complete coordinate at 35 degrees, I keep losing my cursor, 35 degrees, 22 minutes, 30 seconds, you're at about 0.02 miles. You're going to be pretty sure, but emphasize one thing. This is 35 degrees, 22 minutes, 30 seconds. But guess what? Clear down here on the other side of the equator is 35 degrees, 22 minutes, 30 seconds. You have to put in north or south. That's one of the most important things with latitude and longitude that seems to be easily forgotten. I did do a thing here, north and south, because this number, 37 degrees, 37 minutes, 30 seconds, is also in the southern hemisphere, just like that, okay? And then this is 0, longitude, this is 0, this is the prime meridian, but clear around here is 180. So there is a 121 degrees, 30 minute east also. You need a 121 degrees, 30 minute west to tell which side you're on. So these are township and range. This is PLSS. This number 35 is Public Land Survey System. This is how they divided out west of the Mississippi. No, I think it was even further north than east than that. Is the very beginning is when they gave war veterans their land. Go pick your land. Thank you so much for your service, type of deal.
Wish they were still doing that.
Yeah. Oh, you're saying, yeah, that's true, Casey.
But no, that's a question I get every year is what are the red grids on my map? Like Chris mentioned, that's Public Land Survey System. Very, very important if you're going out there to buy land, like say if you're buying a ranch or anything like that. For the purposes of land navigation, we probably won't cover it very much more.
Let me tell you what the PLSS does for you, though. Look at this line here. See, right here is Township 3, Township 4. This line divides Township 3 from Township 4. They're square miles. They're square miles. You'll see them. You'll see them on maps, like Casey said. You'll see them on the Green Trail map. You'll see them on the big maps. This is, you get up in an airplane, you go across the United States, you will see to this day the squared up land of the people. 640 acres in this 1 square mile. And farmers have this, and they will farm this. You can see the circle irrigation, so they miss this corner. You'll see it flying across the United States, township and range. It's called township, and the range goes north and south is the range, and townships are east and west. And this is section 35, 640 acres. But it's really cool when you get on the airplane and you get the person who's sitting by this window who is sleeping, you get them to change places with you. Because then you get to see all this squared up land, and it's like, oh my gosh, I learned that. Anyway, it's township and range is cool too. Okay, back to you, Casey.
Well, yeah, so I just wanted to, Elaine mentioned there are, the older lat long is modeled after the clock with degrees, minutes, seconds. But right now there's also a decimal system. And that's true. There's several different ways to communicate latitude and longitude. One of the reasons U.S. National Grid is now the preferred grid system for land search and rescue is because of that. During Hurricane Katrina, several different search and rescue organizations were volunteering, as well as the Army, as National Guard, etc. And everybody was giving their grid coordinates in different systems.
Oh.
It was very confusing, very hard to get resources to the right point on the ground. So that's why we've switched over to U.S. National Grid, which is one way to say it. It uses letters and numbers, and it's 8 digits gets you to within 10 meters. It's a lot easier to remember 8 digits versus 10, 12, however many you want to get into with decimals. It is still important to know lat long, especially the decimal system. A lot of private websites like, WTA.org, All Trails will use the decimal system of lat long to give you coordinates for trailheads. So it's important to be able to switch your GPS device, whether you're using your phone, whether you're using CalTopo, back and forth between the different coordinate systems. Do we have any other questions out there? Everybody is a pro at reading the topo lines on your map?
Right. That's called it takes practice.
It does.
It's fun. I mean, you're going to sit around at backpacking and look at your maps that you're going to do and go, okay, what about this one tomorrow? Oh, no, that's going up a cliff. What about this one? This will go into a glacier valley. Let's do that one, It's fun.
It's definitely a perishable skill. That's why I'm glad I help. One of the reasons I help teach this class every year is I enjoy refreshing my skills and keeping current on it. The main purpose of this class is to make sure you know what the topo lines look like and what feature you're looking at when you look at a map versus when you look out in front of you and see the terrain. Does everybody have a good understanding of the 5 major and 3 minor terrain features and what they look like on a map?
Casey, you're going to send this PowerPoint to us?
Yep, we're going to make the PowerPoint available after class. It'll be on the Google Drive, and I'll attach it to the email. And the same thing, Elaine, I do consider myself pretty skilled with the map and compass. I still take the wrong turns, and 9 times out of 10, it's because I felt good going off memory and not actually pulling out my map.
Here you go, Casey. And then they're still not sure where they're going.
Oh, I've got a couple good ones. We're going to talk about my Emmons Glacier trip next class. Like I said, there's one time I thought it'd be easier to hike out of the Linville Gorge as opposed to backpacking on the trail, and that was a bad mistake. There's one time.
As long as you can live through your mistakes, hey.
Yeah, I usually come out right on the other side. It's the other people that come with me.
Yeah. Have you noticed you've lost some friends when you've been backpacking? Not afterwards when they finally get back and you say, wasn't that fun? And they're going, and I'm not hiking with you again.
I like to think of it as we really developed our friendship and took ourselves to more intimate settings. So yeah, I think Frenchman Coulee is a great example of, even here, you can see that the topo lines are not 100% on top of each other, even at some places that are pretty much straight up and down.
Right here, yeah. There.
Like that is, for all intents and purposes, straight up and down, but there's still you can still see multiple topo lines there.
Yeah. I highly suggest to our backpacking people to make sure you get out there, be ready for your backpacking trip. And I'm sure Casey's already said it before. It's always, I know Chuck and I, we love it when we're in training. When you're in training for something, I mean, we did South Sisters and we had to go in training. We did Mount St. Helens one Mother's Day trip, and we went in training, and training is good. Right now we don't seem to be in training for anything. We're still hiking a lot, but it's good to be in training, just throwing that out there, find a reason to be in training. I mean, and that just, I know for us it meant just hiking a lot, doing Candy twice instead of just once, and I know even the local hikes.
So New's got a good question. How often do topo map change? And what do you have to keep in mind when you're buying one?
That's a really good question. Like I said, my Badger Mountain topo map is 1965. This is a huge, I use it, like I told you, in the classroom, but the revision on it was 1978. Now, I would think, Casey, that Cal Topo keeps totally up to date, wouldn't they? I mean, they're almost like an ongoing.
You'd be surprised. A lot of their information, like the 7.5-minute quadrangles, are USGS maps. So it depends the last time USGS surveyed that area.
Oh, interesting. Yeah. This Green Trail original issue date was 1977, and it was, the latest revision was 2014 on the Green Trail, on a Green Trail map. But yeah, you're right. USGS, they do a lot of land survey, and they can't update as often. That's a good on you.
Definitely in the map margin, it should show you the last time that map was updated.
Mm-hmm.
So something to keep in mind is things like hills, valleys, ridges. Those don't change very much or very often. But other things like roads, trails, not necessarily rivers, but maybe intermittent streams. So one of the things you have to be wary of, especially with four-wheeler tracks, some of them will be shown on the map, some of them won't. So when you cross not necessarily a big gravel road, but like a small 2-track, that may or may not be on your map. So don't use those as landmarks if you can help it.
Another slide I actually took out was power lines. Power lines, they are suggesting for old versus newer maps, some of the power lines might not be there, especially some of the power lines, smaller power lines might not be there. So don't necessarily rely on power lines on your map as a true source of a location, so.
The other thing to keep in mind is your declination angle. Like Chris mentioned earlier, it changes from year to year. So if you have an older map, it may be helpful to go online. They have websites where you can find the current declination angle and just pencil that in on your map, because it will change.
There it is.
I think it's about 1 degree a year, or I think it's about a ½ degree a year-ish.
Well, and I think this is 2000 to 2010, 10 years, 80 years. I read an article the other day about the magnetic north changing, and it seems to be a lot quicker happening lately than it used to happen. The other geologists online here, have you read anything about magnetic north changing quicker than it usually does? Maybe not. Look right here at 1900, 1920, very little change, but then 1980 to 2000, it's been changing in the last 40 years. Pretty good amount,
Yeah, it looks like 2000 to 2010 was relatively consistent with 2010 to 2020, but it definitely accelerated after 1960.
Yeah.
Let's see, Anu, I'm not sure. I'm gonna put that website in to my browser and figure out.
What was the news question?
He's asked me if I'm pointing to Mount Rainier. I guess I'm unsure. No, not necessarily. I would say oh yeah, the USGS map view. Hey, sorry about that. So I'm in the garage here. I'm running on a 10-year-old laptop. I think it's from 2010. And I think trying to run Zoom and do Chrome at the same time overloaded it, and it shut down on me. So Noon's wondering how we read tree lines on topo.
The tree lines on topo are usually marked in green. It's a green forest. You can get up on one of the maps I use in class. Oh, here's Mount Rainier. I don't know how much you can see this. You can see the green. Can you see it? It's not very good. The green down in here. And then you'll see the white where it's above the tree line. And then you'll see the blue. You see the blue lines on here? Mm-hmm. This is a glacier. This is Mount Rainier. This is an absolutely gorgeous map. I just love this map. You can see the blue lines for the glaciers, and then the white with the contour line above tree line, and then you can see the green for the tree lines. So it's not going to show you a tree.
Yeah, but it will be green shaded.
Yeah, green shaded.
Where there's consistent tree cover versus white where there's not consistent tree cover.
And the one thing, I don't know if it got put in as far as features, the blue lines are glaciers. The glaciers, the blue lines, like on this Mount Rainier map, the contour lines will be blue. Contour lines will be, no, I take that back. I lied to you. The contour lines are still dark. It's just that you can see all the blue in here. Can you guys see that a little bit? A little bit, no?
I can see it a little bit.
A little bit. You can see the blue and the white, and you can see some of the green. And I mean, this is a big map. You know, this is a green trails map, so it's mostly green. But little bit of knowledge, and you'll be able to figure it out.
Yep, especially so if you're watching and you're trying to see this video better. The pin video function works very well.
Yeah, and look at this map. I mean, this map has the blue for the glaciers, and then this is above tree line, and then here's the tree line, trees, the forest, you know, so you can see this right here, the green. So yeah, that's a good question, Anu.
All righty, so I see we hit 8 o'clock. Some people are saying thank you for such a great class. Thank you, Chris. Really appreciate it.
Yeah, it's I love this kind of stuff.
Do we have any last questions out there? Okay, well, thank you everybody for joining. I really appreciate it.
Thank you guys.
As always, feel free to hit us up. We are, we're all very passionate about backpacking and definitely willing to answer more questions as they come up. So definitely shoot me an email and I will put you in touch with Chris or any other instructor you're thinking of.